Okay, as promised, I am recording a problem that is measuring or calculating out the oxygen that's consumed by a subject in milliliters per kilogram per minute. So you're going to start with some standard numbers that are going to be given to you by your gas analyzer, and then you're going to have to do some calculations, and that's what I'm going to go through step by step with you. Okay, also it's already been divided out by kilograms, so you don't have to worry about that. You can focus on the milliliters per minute for this problem. So what's been given is the volume of expired air. It's been given to you in liters, or 0.9741 liters. The volume of inspired air is not given to you. The fraction of the air that was oxygen is 0.1548, or expressed as a percentage is 15.48%. And then the fraction of expired carbon dioxide is 0.0566, or was 5.66%. So the first thing that you need to do is you need to find out the volume of the air that was inspired, and you're going to use the Haldane transformation for that. So if you already got these numbers, I'm going to erase them so that we can do the problem. Okay, so using the Haldane, the volume of inspired air equals the volume of expired times the fraction of that air that was nitrogen, and then divided by the fraction inspired that was nitrogen, which is a given, a standard number. Okay. Now we don't know this number right off the top because we were given the fraction that was expired for oxygen and carbon dioxide, but we don't know what was the fraction that was nitrogen. So you're just going to subtract from 1 the carbon dioxide and the oxygen numbers. And you get the fraction that's left over. That's going to be this number here. So 0.7886 can go in here. Okay, and the volume that was expired was given to you. I'm going to convert it to milliliters here, so I don't have to worry about that later. Okay, and then the fraction that was inspired, which again is a standard number, 0.7904. Okay, and after you have done all the calculations out for this on your calculator, you get $971.9 milliliters for your volume of inspired air. And now we can use that to do the entire calculation. Okay, now that we have determined the volume that was inspired, because all the rest of the information was given to us, we can complete our calculation to determine how much oxygen the subject consumed. So overall, what you're trying to figure out is the inspired oxygen. We're going to subtract the amount that was expired, and what's left over should be the amount of oxygen that the body or the subject consumed during the exercise for that 1 minute. Okay, so our calculation that we got from last lab is the oxygen consumption is equal to the fraction of inspired air, that was oxygen, which is a given, times the volume that was inspired. And then we're going to subtract the fraction that was expired, which we got from our gas analyzer, times the volume that was expired. Okay, I'm going to carry this down so you can see where the numbers are coming from. 0.2097, that's the fraction of oxygen that's in the air, times the volume that is inspired that we just figured out, 971.9 milliliters. Okay, and the fraction that was expired, that was oxygen, 0.1548 times the volume that was expired, 974.1 milliliters. After you do those calculations, you get 203.81 milliliters, and then minus 150.89. Continuing down, what you get for oxygen consumption is going to be 52.92 milliliters. We already know that it's per kilogram per minute. So that is how much oxygen that your subject consumed.